So hello everyone, welcome to OneClass YouTube channel. My name is Devansh and today we are going to go through a few popular mathematics Q&A and a little bit background about myself. So I'm in the final year of my graduation and I'm doing my graduation in aerospace engineering. And if you need any homework help or if you need any tutoring or one-to-one sessions, then you can check the links in the description below. So without wasting our time, let's just move um, to the questions. So here we have the question. Um, Question number one. Use a calculator to evaluate the line integral correct to 4 decimal places. So we have the function um, line integral over curve f dot dr, where f is equal to square root of x plus y I plus y over x j. So these are basically unit vector or unit vector cap. So I'll just write it properly. So this should be square root of x plus y, and this should be I cap, this should be j cap. I and j are the unit vectors, and we have r as sine squared t I cap plus sine t cosine t j cap. So let's see what the junior tutor has given as the solution. So they have given f of x as, so f is the function which is function of x and y plus y over x j cap. Then we have function r of t which is sine square t I plus sine t cosine t j. Now we need to find dr, because the thing is that in our original integral it is f dot dr and we have the r function. So we'll differentiate we'll just differentiate this function and we'll get so sine square t will be 2 sine t and sine will be cosine t I cap plus this will be using product rule. So this will become sine times this will be cosine will be kept constant. So sine is cosine, sine will be cosine t times cosine t, and this will be plus, and then sine will be kept constant and my cosine will be minus of sine, and this will be dt whole multiplied by dt. So I'll just simplify this. Dr is let's say, okay, let's just stick with 2 sine t cosine t I cap plus cosine square t minus sine square t j cap, and this will be dt. Now this is, so basically what we are doing is that we are finding f of r of t. So f of r of t, and this is going to be, so in this function we are going to keep the value of the say it is like a composite function, so we are basically calculating g of x or g of f of x or f of g of x. So in the composite fashion, what we do here, in the place of x, um, what was the function? It was sine square t, sine t cosine t. So we'll just put this and we will have okay, so we'll write square root of sine square sine square t plus sine t cosine t I cap, and then plus we have this was y over x, so we have sine t cosine t over sine square t, and this will be j cap. Now we need to find the line integral c f dot dr. Now my f function is in terms of t, and my dr was always in function of, always a function of t. So this will become f dot dr over the curve c will become f function f of r of t. So sine square t plus sine t cosine t and then sine square t sine t cosine t I cap plus sine t, I'll just write it here, I'll just write this again, sine square t plus sine t cosine t square root I cap plus sine t cosine t over sine square t j cap multiplied by, or basically the dot product with, this was my r of my dr, so dr was 2 times sine t cosine of t I cap plus cosine square t minus sine square t j cap, cosine square t minus sine square t j cap times dr. Now we'll be going to take the dot product. So in the, when we take the dot product, we have let's just see the solution which we have at this point. So okay, when we take dot product, then I dot I is 1, j dot j is 1, and I dot j is equals to j dot I, which is 0, and this is a dot product, so we'll just take the dot product, f dot dr. So this means that um, this particular term is going to multiply with this particular term, and this will multiply with this. So I will write square root of sine square t plus sine t cosine t times, or just multiplication sign, and 2 sine t cosine t plus, then we have sine, then this term is going to multiply with this term, and sine t cosine t over sine square t multiplied by cosine square t minus sine square t. So here when we take what is the curve given, okay, so limit we have t is from pi over 6 to pi over 3. So we just needed to simplify till this point, and then we are going to use our calculator to evaluate this integral and find the value. So using the calculator evaluate the integral. So the integral is going to be from pi over 6 to pi over 3. We go for f dot dr, and let me just use my calculator and find this value. If I use basic integration, this will become sine of 2t, this will become sine of 2t. Okay, calculator is needed at this point of time. So it is 2 times of sine t cosine t this is quite difficult for me. So this is square root of, and then we have sine how to take this square. I will take this right sign, and then my sign variable is t, so here I'll just write x, and then plus I need a bracket here, and then a bracket close, and this will be raised to the power 2, then plus, then sine t, sine x multiplied by cos of x, and then square root is completed, multiplied by 2 into sine t cosine t, 2 into sine t into cosine, okay, sorry, it was x into cosine of x. This will be in the bracket, this whole term. Then we have plus, and then we have another bracket open, and in the bracket this will become cosine over sine. This will become cos of x, cotangent of x, cotangent of x, and this will be multiplied with bracket open cosine, one more bracket for square, cosine x raised to the power 2, here is 2, and then we have minus sine, minus of sine, we have x, and then it will be raised to the power 2, and so sine square x plus sine x cosine x times 2 into sine x cosine x plus cotangent. Okay, this is cotangent and cosine square minus sine square. Now my upper limit is going to be this is pi by 3, so pi by 3. I'll just write the value of pi 3.1, if pi was 3.12 by 3, and lower is 3.12 by 6, and then processing the result. Okay, this calculator is taking huge time. So yeah, so the result is correct. It is 0.542425. So the solution given here is correct. Great job. This question took a lot of time because questions like these take some time to solve. Like this was not a short question, and if we do not had any calculator, then it would have taken a lot of time to solve this question. So we'll go to question number 2. In what quadrants will an angle in standard position have a positive tangent value, and what is a unit circle? So if I draw a unit circle, let me just first write the question. The first part is in what quadrants angle. So we need tangent as positive in which quadrants. Uh, uh, which quadrants? And we have B part is what is unit circle. So we'll start with the A part. Let's draw a unit circle, and I'll just manually draw the axis. Let's say this is x-axis, this is y-axis. So let's say this is positive direction and this is positive y, this is negative y, and this is negative x. This point is 0. Let's say the coordinate at 45 degree is in this it will be 1 over root 2, 1 over root 2, and for here for 135, I'll just make this like this. 135 degree, we have x will be negative and y will be positive here. Here it will be, I think it is going to be 225 degree, and my x and y both are going to be negative. And here this is going to be 315 degree, and here my y coordinate is going to be negative because this is the negative y-axis. So my x and negative of y. Now for a unit circle, tangent of any angle, say theta, is basically y by x. So y coordinate over x coordinate. Now let's see for first quadrant. We have tangent of 45 degree, which will be equal to 1 over root 2, 1 over root 2, and this will be positive. For second quadrant, we have tangent of 135 degree. Now in this my x is negative 1 over root 2 and my y is positive, so this will become negative. For my third quadrant, tangent of 225 degree will be negative of 1 over root 2, negative of 1 over root 2, and this negative and negative will be cancelled, so this will become positive. For my fourth quadrant, this will be tangent of 315 degrees, and here in the fourth quadrant my y is negative and 1 over root 2, and this will become negative. So we can see that in the first quadrant my tangent was positive and in the third quadrant my tangent was positive. So tangent of any angle will be positive in first quadrant and in third quadrant. Well, this question, the way of asking this question is not like correct, because first they should have asked what is unit circle, and then they should have asked what is like in what quadrants tangent is positive, because um, we just found that tangent is positive in first. This is first quadrant and this is third quadrant. This is second quadrant and this is fourth quadrant. So we just found out that in the first quadrant tangent is always positive, and in the third quadrant tangent is always positive. And there is one more reason, like the tangent is basically y by x. So here we can see in the first quadrant all the values of y and all the values of x is going to be positive. So therefore my y by x is always going to be positive. And in the third quadrant my x and y both are going to be negative. So negative over negative is going to be positive, and therefore in the third quadrant my tangent is positive. Now I will start with B part. Let's just see what the junior tutor has given. The tangent function is positive in first and third quadrants. And for unit circle, in mathematics a unit circle is a circle with a radius of 1. In trigonometry, the unit circle is the circle of radius 1 centered at the origin 0, 0. In the Cartesian coordinate system, in the Euclidean plane, the point of unit circle is that it makes other parts of the mathematics easier and neater. For instance, in the unit circle, for any angle theta, the trigonometrics of sine and cosine are clearly nothing but sine theta is y and cosine theta is x. Well, this part is not, I cannot guarantee this part as is if it is correct, but yeah, this is basically correct because when we take the, so I'll just draw a circle here again. So as we can see this circle, this is a unit circle. So suppose this is the axis, say, and this unit circle lies, its center lies at 0, 0, and it has a radius of 1. So this is just basically a unit circle, but it helps a lot in trigonometric to find trigonometric angles and trigonometric ratios. This circle helps a lot because if we see that whenever I draw a radius, it will be of 1 unit, and I can draw this radius at any point. I can draw it from here, I can draw it from here, I can draw it from here, I can draw this here also. But when I just drop down a perpendicular on the x-axis from these radius, then let's say these all are perpendiculars, then this so basically whenever we draw a perpendicular we get a triangle, and the hypotenuse of that triangle is always going to be 1 unit. And this is a kind of benefit for us because we already know the hypotenuse, we know the x and y coordinate. So x and y at this place, x and y at this place, and x and y at this place, we know the coordinates, so we can just find out this distance and the perpendicular distance, and we can just find out the distance from in the x direction. And then so eventually we get a right angle triangle whose hypotenuse is always going to be 1 unit, whose x and y coordinates we know, and therefore we can just calculate the trigonometric ratios of any angle because this unit circle covers whole 360-degree. So we can calculate sine of x, then we can calculate cosine of x, and we can calculate tangent of x. And sine is going to be always y, just y coordinate of the unit circle is going to be my sine x. My x coordinate of the unit circle is going to be my cosine x, and my y by x is always going to be tangent of x. So we without using any calculator, we can just find the values of any angle using this unit circle. The circumference of unit circle is 2 pi, so yeah, that is true. So basically pi is basically the ratio of circumference of a circle to its radius and to its diameter basically. So we get circumference as 2 pi r, and this r is 1 here, so we get 2 times pi. An arc of a unit circle has the same length as the measure of the central angle that intercepts that arc. Also, because the radius of the unit circle is 1, the trigonometric functions sine and cosine have special relevance for unit circle. The solution given here is correct. And great job. Hmm, Now we move towards question number 3. So, geometry of the area of the ellipse in the figure is twice the area of the circle. What is the length of major axis? So, my major axis is this one, this x-axis, which is from negative a to positive a, or basically 2a, and we have a circle given in this question. I may draw, or I am not going to draw this figure again, and then we have a circle and we have an ellipse. So the area of circle is half as area of ellipse. And let's see the solution given by Junior Tutor. So we have the minor axis coordinates, which is from negative 10 to positive 10 or 20 units, and we have the coordinates for, I think the center for this center is going to be 0. Yep, center of the circle is 0 comma 0, and the radius of this circle is 10 units, because we can see that in this we have 0 comma 10, and this is going to be from center, so my radius is 10 units of the circle. And let's see, okay, so area of the standard ellipse. Now equation of ellipse is, or area of standard ellipse is pi times AB. And so what we do here, we in the question it is given that I'll just write, first I'll write area of ellipse, and I'll write area of circle. Now the ellipse in the figure is twice the area of the circle, so ellipse is basically 2 times of the circle. This is basically pi r square. Yeah, I cannot write equal to right now. Yeah, so the area of ellipse is 2 times of area of circle, so pi AB will be equal to 2 times of area of circle. Now I can divide both the sides with pi, and I will get AB as 2 times of r square. Now my r is basically B was 20 units, or B was, let me just see, B is going to be 1 unit. Uh, mm, B is basically 20, 2 times of okay, so B is going to be 10 only. This is plus B, this is minus B. Yeah, B is going to be 10. So I write A into 10 equals to 2 times 10 into 10. Basically 10 into 10 is the R square term. I can divide both the sides with 10, and then my A will be 2 times of 10 will be 20, and my major axis is 2 times of A. So this will become 2 times of 20 will be 40. So let's see the solution. Yeah, length of major axis is 2A, which is 40 units. We should always write units because the unit is not given here. So the given solution is correct. Given solution is correct. Good job. Now we have question number 1, 2, 3, 4. This is going to be our question number 4, and we have, what is the formula for surface area of a cylinder? Okay, so surface area of a cylinder. So basically, cylinder is a 3D figure. Surface area of a cylinder. So a cylinder is a 3D figure, three-dimensional figure, and if we see a cylinder is something like this, we have one more circle at the bottom. Um, yeah, something like this, and we have this is height, this as the radius, and both top and bottom surface will have same radius. So surface area is basically, we have two types of surface area for curve shapes. One is the curved surface area and second one is the total surface area. So curved surface, total surface area is basically area of circle, and for area of this top circle, so I'll just write TC, top circle, plus area of bottom circle, this one, and plus area of this curved surface. So total surface area is the area of this circle plus area of this bottom circle plus area of curved surface. Now area of top circle and bottom circle, because as the radius is equal, so this area of top circle is equal to area of this bottom circle. So in this case we'll have 2 times area of let's say just circle here, no top no bottom, area of circle plus area of curved surface. Now let's the area of circle is basically pi r square. So 2 times will be 2. Basically we'll just multiply this with 2 to get this term. Now we need to find area of curved surface. So when suppose if we open a cylinder, then we'll get a rectangle surface. If we open this curved surface, or if we just cut this cylinder from one side, then this curved surface will basically convert into a rectangle. So this rectangle, um, I'll get a rectangle surface. Now my height of the cylinder is going to be the breadth of my rectangle. For the length of my rectangle, basically the length of the rectangle is going to be the circumference of this circle. So because as here also you can see the length of the rectangle is going to be the circumference of the circle, because suppose when we open a cylinder, then the circle, the curves of, or the circumference of the circle is going to be the length of the my rectangle. So this will become circumference is 2 pi r, and area of this rectangle is length into breadth. So my area of curved surface will be length is 2 pi r, breadth is h. Now my total surface area will become 2 times of area of circle, which is 2 times of pi r square, plus area of curved surface. So this will become 2 pi r times h. I can take this 2 pi r common. So I'll get r plus h. So this is the total surface area. Now we have one more surface area, which is curved surface area. So we can calculate this curved surface area by, so this curved surface area is nothing but the area of this rectangle. Curved surface area is just 2 pi r times h. Or we can also say this curved surface area as lateral surface area. Um, whatever term you like, you can just, the basic concept is clear. And the area of the circle, two circular bases, then we have TSA, total surface area is 2 pi r plus h. So the solution given here is correct. Is correct. Good work. We have question number 5. How do you check solutions when solving one-step equations? So one-step equations. So let's see the solution given by Junior Tutor. So we have to check the solution. To check the solution when solving one-step equation, we substitute the calculated solution in the equation and see if it satisfies the equation. For example, if we solve the equation x plus 2 equals to 6, so this is kind of very easy. We have the equation x plus 2 equals to 6. I will just subtract 2 from both the sides, and I will get x as 4. To check if the computed value of x is really solution to the equation, we just substitute x equals to 4. So we'll substitute x equal to 4 back into this equation, equals to 6, which implies 6 equals to 6, and my LHS is equal to RHS. Therefore, it satisfies the equality condition. and therefore x equals to 4 is the solution of this equation. I can take one more example. Let's say x plus 32 equals to 9. Then in this equation I'll subtract 32 from both the sides. 9 minus 32 will have x equals to 9 minus 32 will be 2 and 7, so this will become 23. Yeah, this will become 23. Now I'll just substitute the value of x as 23 back into this equation. So 23, this will be negative of 23 because 32 was negative. Negative 23 plus 32 equals to 9. So if we just do the subtraction, we get 9 and 9. So again, LHS equals to RHS. So in this way, we just um, substitute the value of x back into the equation to verify that the value which we have got is actually the solution of x or not. Actually, is the solution of the equation or not. So correct solution. Great job. This was question number 5. This is going to be my question number 6. Okay. So trigonometry identities, derive and proof. So let's see what the junior tutor has given. So the trigonometric identities are equations that are true for right angle triangles and trigonometric functions. They are helpful in simplifying more complicated trigonometric problems and in proving other trigonometric statements. Moreover, some identities can be easily proven using other identities which can be seen below. So suppose we have a right angle triangle. And let's say this angle as theta, and this is hypotenuse, this is opposite side, and this is adjacent side. So my sine of theta is going to be opposite side over hypotenuse. My cosine of theta is going to be adjacent side over hypotenuse, and my tangent of theta is opposite over adjacent. Now tangent of theta is also equal to sine of theta over cosine of theta. So if I put the value of sine theta, which is opposite over hypotenuse, and cosine, which is adjacent over hypotenuse, and this will become opposite over adjacent. So in this way I can just prove that tangent is actually sine over cosine. Then we have double angle identities. So we have double angle identities as sine of x plus y is sine x cosine y plus cosine x sine y. Then we have this is sine. Then we have, okay, so with this identity we can prove that sine of 2 x is basically 2 times of sine x cosine x. So if I put x equals to y in this equation, then I will get sine of 2x, and this will become sine of x. Then I have cosine of x plus cosine of x, and I have sine of x again here, and this will become 2 times sine of x cosine of x. In the similar fashion, we have cosine function. So cosine of x plus y is cosine x cosine y minus sine x sine y. Again, if I put x equals to y here, then I will get cosine of 2x equal to cosine x minus sine x sine of x. This will become cosine square of x minus sine square of x. Now I use the identity sine square x plus cosine square x equal to 1, and I can, so if I just subtract sine or cosine, this will become cosine square x equals to 1 minus sine square x, and sine square x is 1 minus cosine square x. Then in this equation I can substitute the value of cosine x, or I can substitute the value of sine x. So if I substitute the value of cosine x, I will get 1 minus sine square x minus sine square x, or if I substitute the value of cosine x, I will get cosine square x minus 1 plus cosine square of x, and this will become 1 minus 2 sine square x, and this will become 2 cosine square x minus 1, and these both are equal to cosine 2x. So the same solution is given by Junior Tutor, and we have tangent of x plus y, which is equals to tangent of x plus tangent of y over 1 minus tangent of x tangent of y. Again, if I keep x equals to y, I will get tangent of 2x as 2 times tangent of x over 1 minus tangent square of x. Oh god, this. And half angle identities, we can just keep x as x over 2, and in the similar fashion we can just derive, and we have cosine function cosine 2x equals to 2 cosine square x minus 1. Then we have cosine x over 2 as square root of 1 plus cosine x over 2. So for tangent also we have sine of x over 2 and cosine of x over 2, and so the solution given here is correct. Great job. This was question number 6. So we have question number 7, What is the limit as x approaches to infinity of arctangent x? So limit of x as tangent inverse of x approaches to infinity. So for this we can use the graph of tangent of x. So if we see the graph of tangent of x, we can see at 0, at x equals to 0, or not x equals to 0, at pi by 2, my tangent of pi by 2, not, sorry, not tangent, first I'll just start with 0. So at 0, my tangent of 0 is 0. So along y-axis, there is tangent of the x coordinate, and along x-axis we have x coordinates. And if we see when my x coordinate is pi over 2, then my tangent of pi over 2, it goes towards infinity. This is because this never reaches infinity, it approaches to infinity. So if I take the inverse here, tangent of pi over 2, and is equal to tangent inverse of um, let's say h, where h approaches to infinity. Then my pi over 2 is tangent inverse of h, where h approach to infinity limit. Because in case of infinity or zeros, we just not substitute 0 or infinity. We need to use limits to substitute those. So if we see the arctangent function, we can see that my or when my angle is pi over 2, then my tangent is approaching to infinity. So whenever my tangent inverse is approaching to infinity, tangent inverse of x is approaching to infinity, my angle is going to be pi by 2. Yeah. So the solution given here is correct. Solution is correct. Great job. This was question number 7. Let's start with question number 8. So we need to calculate the projection of a u vector along V, and we need to resolve u into u1 and u2, where u1 is parallel to V and u2 is parallel to, orthogonal to V, and u is vector of 1 comma 1, V is 2 comma negative 1. So for projection, we have a formula. So if you want to take the projection of u along v, we have a formula which is v dot u over v square times v vector. So here we'll have 1 comma 1 dot 2 comma negative 1 over v is under root of, not under root, yep, this is going to be under root magnitude. We need to find the magnitude of v, 2 square plus negative 1 square, and we'll take the whole square, and it is 2 comma negative of 1. So in the case of dot product, we multiply 1 with 2. So I'll get 2, and we multiply 1 with negative 1. And this will be 2 square will be 3, 4, and this will become plus 1, 5. So square root of 5 square. This will be 2 comma negative 1. And this will become 1 over 5 times 2 comma negative 1. So this is the projection of u along v, and I can also simplify this as 2 over 5 comma negative 1 over 5. Now going towards b part, it is given that u1 is parallel to v, so we have the formula u1 is going to be projection of u along v, which we have already found that 2 over 5 and negative 1 over 5. So u1 is going to be basically 2 over 5 and negative 1 over 5. For u2, it is orthogonal to v. So we have u2 as u minus projection of u along v, or we can also say this as u minus u1. u2 will be, what was u 1 comma 1, 1 comma 1 minus 2 over 5 comma negative 1 over 5. This will become 1 minus 2 over 5 comma 1. This minus minus will become plus, to 1 over 5. And if I take the LCM, this will be 5 minus 2, 3 over 5 comma, and this will be 5 plus 1, 6 over 5. And the solution given here is the same. Okay. So the solution given here is correct. This is going to be correct solution. Great job. This was question number 8. We have question number 9. So what is Maclaurin series formula? Maclaurin series formula. So the Maclaurin series is basically a special case for Taylor series, and Maclaurin series is derived using the help of Taylor series. So I can write first. I'll start with the Taylor series. So let me just quickly see Taylor series. So Taylor series, suppose we have a function p of x, then we can expand this um, in terms of f of a plus f prime of a over 1 factorial times x minus a plus f double prime of a over 2 factorial, and this will be x minus a whole square, and this will keep on continuing until the nth term a over n factorial, and this will be x minus a power n. Now this was the Taylor series, and Maclaurin series is basically a special case of Taylor series where this a is equal to 0. So my Maclaurin series will become which will be f of x is f of 0 plus f prime of 0 over 1 factorial times x plus f double prime of 0 over 2 factorial, and this will be x square, continue till f of nth derivative of f over n factorial and x power n. And in the summation form also, or the general formula, we can just write f of x as this will be summation of n equal to 0 to infinity n equal to 0 to infinity, and this will be n 0 n factorial, and this will be x power n. So the general formula, the answer of Maclaurin series, and this is the Maclaurin series. So let's just read the definition of Maclaurin series. So named after Scottish mathematician Colin Maclaurin, the formula in 2, which is that Maclaurin series, is one of the various methods to approximate a given function, example logarithmic, exponential, and trigonometric, using polynomials. So the solution given here is correct. Solution. Great job. Now this was question number 9. Question number 10. We need to find the tangent line approximate to f of x equals to 1 over x near 1. So we need to find tangent line basically at the function f of x at x equal to 1. So Whenever we have any equation and if we want to find the tangent at a particular point or the tangent line at a particular point, what we do is that we just take the derivative of that function and we keep substitute the value or the coordinate of that point into the derived equation, and which that gives us the tangent of the function. So I will take basically derivative of f of x, which is equal to derivative of 1 over x. Now in this I'm going to use the power rule of derivative. So let's say d dx of x power n is n times x power n minus 1. So for 1 over x, I can write this as x power minus 1. Therefore, d dx of 1 over x can be equal to d dx of x inverse, and by using this rule I can write x minus 1 and this will be minus 1. So this will become negative of x and this will become negative of x 1 over x square. Now we need to find the tangent at x equal to 1. So we'll just substitute the value of x as 1 and it is negative of 1. Using the power rule for derivatives, then we have x equal to negative 1. Now substituting this into L of x, we have, let's see what is L of x. We find the answer for the linear approximation. Lx equal to f of a, f prime of a. For linear approximations, we want both f of a and f prime of a so that they are easy to calculate. In this case, f of 1 and f prime of 1 are easy. So, this was just the tangent. Okay. So if I come here and the equation of line will become f of a, f prime of a times x minus a, and my x is going to be 1 here, I think. So let's calculate f of 1, and f of 1 is going to be 1 over 1, which is 1, and we have f prime of 1, which is negative of 1. So we have L of x equals to 1 minus 1 into x minus 1, and this will be 2 minus x. So the solution given here is correct solution. Great job. Yep. So, what is unit circle? This is going to be question number. I think this is going to be question number 11. Yep. So we have question number 11. What is unit circle? So I'll just draw a circle. Actually, I think that we have already done this question before. So basically, a unit circle is a circle uh, with a radius of 1 and the center coordinate are at 0 comma 0, and the speciality of unit circle is that unit circle is helpful to calculate trigonometric ratios of any angle, because the liberty or the benefit of unit circle is that if I draw a radius here, and suppose if I draw a radius from here, if I draw a radius here, and let's say one from here, then all my radius is going to be 1 unit, because this radius of the circle is 1. And if I drop a perpendicular from each and every radius to the x-axis, and this one goes here, uh, all the perpendiculars, then basically, so for radius I have the coordinates x comma y. For each and every point I have the coordinates. Here also I have coordinates, and here also I have the coordinates. So the thing is that if we draw a perpendicular, then we get a right angle triangle, and this is a right angle triangle in which the hypotenuse is 1, and therefore, and we know the coordinates of this point, which is x comma y, and y is going to be this much distance and x is going to be this distance. And let's say this angle is, let's say this is the angle for which we want to find the trigonometric ratio. Let's say this is the another angle, or basically this is the angle, this is the angle. I just, this is the angle. Then for this case, from positive x-axis will come and all the way here, this is the angle, and we can say this is the negative of whatever angle we have here. So we can just find the trigonometric ratio of any angle, and as this is 1, hypotenuse is 1, my sine of, let's say, theta is going to be y. This will be y over 1, which will be y. My cosine of theta is going to be x. Let's say this is theta. This will be base and hypotenuse, and then my tangent of theta is going to be y over x. So a unit circle is basically just a circle whose radius is 1. From this circle, different angles can be derived depending on how you slice it up. These angles can represent in degrees, can be represented in degrees or radians. So in this way, we can use the unit circle to calculate tangent, sine, and cosine for any angle, or we can calculate trigonometric ratios for any angle. The thing is that we just need to know the coordinate of that point. So the solution given here by Junior Tutor is correct. Great job. And solution here is correct. This is going to be question number 11. Question number 12. So question number 12 states that what is extraneous solution? Okay. X-ray. So I'll just tell you the basic definition of extraneous function. So whenever we have the roots of any equation, and suppose we transform that equation, I'll just start it like suppose if we have any equation, then the value of the dependent variable or value of the, suppose if I have an equation f of x, then the domain of x is going to be a different domain. And suppose if I take the square, or if I take the square root of f of x, or if I transform that equation to just find the roots, then my domain of x is going to be it is going to be a different domain. It is going to be a kind of bigger domain. And when I put that value of when I put the value of the other domain back into my original equation, then it is not going to satisfy the equation. So this sounds kind of confusing, but I'll just tell you this with one example. And this example here, we have an equation, square root of x minus 1 equals to x minus of 7. And so the domain of this equation, suppose let's say this is the domain of this equation, and my x is going to be in this domain. Now if I take square on both the sides, then we get x minus 1 equal to x minus 7 whole square. And in this case I have a different domain of x. Now though these two equations are derived from each other, but the domain of this equation is different from domain of this equation. Now I'll just solve this equation to find the value of x. So what we'll do, x minus 1 equals to x square plus 49 minus 14x. I will subtract x minus 1 from both these sides, and I will get x square. This will be minus of 15x, and this will be plus 1, this plus 1, 50 equal to 0. Just for simplicity, I'll just take the values from here. So I'll distribute this middle term as 5 minus 10x plus 50 equal to 0. Now I'll take x common. I'll take negative 10 common here. Minus 5 equal to 0. 5 x minus 10 equal to 0. Now according to this condition, my roots of this equation is 5 and 10. Now the actual thing comes here. So whatever I was talking about, you are going to see the actual thing from this step. So if I keep x equal to 5 back into my this original equation, so let me just write my original equation. It was square root of x minus 1 x minus 7. So if I write x equal to 5, then this will become 5 minus 1, and this will become 5 minus 7, and this will be 4, and this will become 2, and 5 minus 7, this will become negative of 2. So you can see that x equal to 5 is not satisfying this equation. Now we'll go for 10. 10 minus 1 equal to 10 minus 7. We will be having square root of 9, which will be 3, and 10 minus 3 is 3. You can see that x equal to 10 satisfies this equation. So x equal to 10 is the solution of root of the equation of this one equation. But x equal to 5 is called the extraneous solution. So it is basically the I'll just read the technical definition from here. So the extraneous solution is the solution or root of the transformed or simplified form of the given function. These solutions do not satisfy or are not valid solutions to the original form of the function. So you can see that in this domain we have x equals to 5 and 10, but in this domain I only have x equal to 10. So this 5 is going to be called as the extraneous solution. So 10 minus 7, 3 is equal to 3, 2 is not equal to 3, 2 is not is equal to negative 2. So here we can see that out of two roots we have obtained only one satisfy the original equation, and that is as x equals to 10. Therefore the root x equals to 5 is an extraneous solution because it is a solution to the transform function but not a valid solution to the original function. Again, the solution given here is correct. Great job. And yep, so we have another question, and this should be question number 13. How to convert the polar equation r equal to cotangent of theta cosecant of theta into rectangular form or into Cartesian coordinate system into rectangular. So let me just draw the coordinates. Mhm. Yep. So let's just say this is y-axis, this is x-axis, this is the origin point, and we have, let's say this is the point P of r comma theta and P of x comma y. So this is going to be my y distance and this is going to be the x, and here this is r and this is theta. So using trigonometric relations we can see that r is or x is basically r into cosine of theta. or if I take cosine of theta, it will be x over r. Sine of theta is going to be y over r. So x is r times cosine theta, y is r times sine theta. Now what they are doing here is that they are taking the cotangent and cosecant and they are substituting the r equal to cosine theta over sine square theta. This turns out r sine square theta is cosine theta. Mm, okay, so I will just write first cotangent of theta, which is cosine theta over sine theta, and cosecant theta is 1 over sine theta. Now r is equal to cosine theta over sine square theta, which implies sine square theta times r is cosine of theta, and then we have, well, let me just see that they are multiplying both the sides with r. Okay, yeah, so okay, now I got it. So I'll just multiply both the sides with r in this equation. So r square sine square theta is basically the original equation which we had was r equal to cotangent theta cosecant theta. So therefore we had r as cosine theta over sine square theta. Now I will write cosine theta, and I can write r sine theta, and I can write r cosine theta. And r sine theta was x. No, r sine theta was y, and r cos theta was x. And this is the equation of a parabola. So you can see that the better curve or better graph given is on this screen. I can also draw a parabola here. So this is the equation of a parabola whose vertex is at center or 0 comma 0, and which is in the positive x direction. So the solution given here is correct. Solution. Great job. We have question number 14. So find the equation of tangent lines, graph the two, they should be para, they should be parabola, I think. Graph the two parabolas, okay. Yep, this should be parabola. So we have one equation is x y is equals to x square, and we have one equation is y equal to x square plus 2x minus 5. In the same coordinate plane, find equations of two lines that are simultaneously tangent to both parabolas. Okay, so equation of tangent lines is not, this is not the equation of tangent lines. For equation of tangent line, so for first parabola, the equation given here is this. Second parabola is x square plus 2x minus 5. Now for first parabola, the equation of tangent line will be the derivative of y, and this is going to be 2x. For second parabola, equation of tangent line is going to be 2x plus 2. Now, why this is minus? I don't get it. There is a mistake here. This shouldn't be minus. This should be plus 2x plus 2. But the slope of tangent of but the slope of this is negative 2, and the slope of 4. Slope of tangent of y equals to x square is positive 2, and slope of tangent line of y equal to x square plus 2x minus 5 is also positive 2. It is not 4, it is 2 here. So let me just find that for the slope of this tangent line, we can just take the derivative and it will be 2. For slope of this tangent line also it is 2. So the slopes are same. So we are going to use y minus y1 equal to m into x minus x1. Therefore, the equation of tangent line y equal to x square is y minus 1 equal to negative 2 times x plus 1, that is y equal to negative of 2x minus 1. How do we get y1? I am not sure. Y minus y1. Okay. Y minus y1 m times x minus x1. If I use 1 comma 1 as x1 y1, then I can write for first parabola, this is going to be y minus 1 equal to 2 times x minus 1, y minus 1 and minus 2. This will become y equal to 2x minus 1. This is the equation of line for first one. And for the equation of tangent line, This equation was 2x minus 1, and let me just verify that the solution here is y equal to x squared. Then the equation, first of all they change the equation, and then the same coordinate will find the equation of two lines that are simultaneously tangent to both parabolas. Okay, so both slope of tangent line is -2, and the slope of other tangent line is 4. I don't know how. Then we have, they have taken at 1 comma 1 and y equal to 4x minus 4, y equal to x squared. I'll just go with this equation. So for the other equation, they have taken the coordinate as 4 comma 2. For other equation, we have y minus 2 comma 4. Y minus 4 is equal to 2 times x minus 2. So this will become 2x, and this will become plus 2. 2x plus 2, and the graph of the parabola with two tangent lines is, so the table for this one and table for the other line. Let me first check the parabola. The other parabola is either there is a printing mistake in the question itself, because this should be y equal to x square and this should be y equal to, okay, so there is a printing mistake in question itself, because if I see y equal to x square is going to be like this, and x square plus 2x minus 5 is also going to be something like this, and our tangent line from here, then from here, they cannot have a tangent line like this. So I'll just correct. So basically the question given here is wrong. I'll just write a minus sign here so that we get opposite directions, and then we'll take the derivative. So for this we have y prime as 2x, and for this we have y prime as negative 2x plus 2. Then we'll just use the equation. So we'll go for y minus 1. For the first, for y equal to x squared, it will be negative of 2 times x plus 1, and this will be negative of 2x, and this will become minus 1. Yep. And then for the second parabola, we have y minus 4 equal to 4 times x minus 2, and this will become y equal to 4x minus 4. Now, and the graph of the parabola with two tangent line is, so the table for equation, so for y equal to negative of 2x minus 1, we have coordinate 0, negative 2, 1, and this we have negative 1, 3, negative of 3. Then for this was this, and for other one we have x over y, negative 4, 1, 0, 2, and 4. And then if we draw the parabola, we get these two lines, and these are the coordinates at which these lines are tangent to the particular parabola. There is some error in the question or in the solution, because if the equation of second parabola is x square plus, this was x square plus 2x minus 5, x square plus 2x minus 5, then both the parabolas will be facing positive y direction, and therefore they will not have a common tangent. But in the solution given here, sign of the equation has been changed, and therefore the second parabola is facing downwards, and hence they have common tangent lines. So either question is wrong or solution is wrong. So this solution is kind of incorrect because there are some errors. And this was question number 14. I have question number 15. What is the square root of 10? So square root of 10, if I distribute it in prime factors, this will be 5 into 2, and 5 and 2, they do not have pairs, so they cannot be further distributed. Yep. So square root of 10 is 5 times 2, and 5 and 2 cannot be further distributed in prime numbers. So what we are going to do here is we are going to find the square root of, like in simple radical form, square root of 10 is the simplest radical form. But if we need to find the exact value of square root of 10, what I can do is that either I can use the calculator. So using the calculator, square root of 10 is 3.1622. Or if we do not have a calculator, what we can do is that square root of 10 lies in square root of 9 and square root of 16. Then I'm going to divide, this is 3 and this is 4. I'm going to divide 10 with 3 and this will give me 3.33, and I will take the average of 3.33 plus 3. This will become 3.16, and let's check the square of 3.16. 3.16 square will be 9.98. So we are pretty close, but we need like okay. So like if we see that we have the correct solution till 2 decimal places, so we can just leave it till here. So square root of 10 is approximately 3.16. Is the simplest radical form. Then square root of 9 and 16 to 3.11, 3.16 and 3.17. So square root approximately 3.16, and hence the solution given here is correct. Good work. Now this was question number 15. This is going to be question number 16. So a pentagon is formed by placing an isosceles triangle on a rectangle. The pentagon has a fixed perimeter P. Find the lengths of the side of the pentagon that maximize the area of the pentagon. So we have the figure, like I'll just draw a rectangle, then I'll draw a yeah. Wow, perfect. Now Lagrange, let's see the solution given by Junior Tutor. So we have Lagrange multipliers are used to find the maximum minimum values of function f of x, y, z. It is defined as gradient of, so here my this side is equal to this side, and this is y, this is h, this line is h, and this angle is theta. Um, Okay, so let's see the solution. So I'll use the red pen. So we have function of x, y, t is lambda times gradient of another function. Now, for this, where lambda is Lagrangian multiplier and this sign denotes the gradient of the function or partial derivative. And this is, now let's see the dimensions of the pentagon as x, y, and z. So let's say this dimension is z, and perimeter of pentagon is fixed, which is given as this should be x. So perimeter is going to be it is going to be this x, and this line is not there in the pentagon. It is a dotted line. Yep. So perimeter will be going to be x plus this y and this y, 2y plus this z, and as this is an isosceles triangle, so this will be z, and this is fixed. Now my area is going to be area of rectangle plus area of triangle, and area of rectangle is going to be length into breadth x into y plus area of triangle is half, base is my x, half base into height. So height is going to be, height we can calculate from Pythagoras theorem. So this is basically x over 2. So x over 2 whole square plus h square equal to z square. H will be under root of z square minus x by 2 whole square. So this is going to be z square minus x over 2 whole square. And now we have so okay. Okay, so we'll just simplify this further. X into y plus half of x. I'll just take the LCM, and this will be 2 square, so this will become 4, and this will be 4 z square over 4 minus x square, and this 4 can come out of the square root. X times y plus, so this will become 1 over 4 x times under root of 4 z square minus x square. So let's say this function as f of x, y, z. Let's say this is g of x, y, z. and this as f of x, y, z. Then for gradient, we'll just differentiate this partially. So we'll get for y plus 2z square minus x square over 2 times square root of 4z square minus x square, and derivative with respect to y will be only this, and with respect to z this term will not be there and this will be constant, so it will be xz over 4z square minus x square gradient of g of x y z. What was g of x y z? I'll just take this from here. The derivative with respect to x will be 1, y 2, and this will be 2. Now we'll go back and we'll use this Lagrangian property and we'll keep the value of f gradients in this equation. So I will keep this equation was y plus 2z square minus x square over 2 times under root of 4z square minus x square x and xz over square root of 4z square minus x square, which is lambda times 1 to 2. Now this will be y equal to no, not y. So in this case we'll just distribute these terms. So first term will be equal to first term of this, second term will be second term of this, third term will be third term of this. So we have y plus 2 z square minus x square over 2 times minus x square, which is lambda. Then we have x equal to 2 lambda. Then we have xz over 4z square minus x square as 2 lambda. Okay. So basically we are going to solve this system of linear equations, and this can be easily solved using a computer, but solving this manually is going to take a lot of time. So I'll just take the values from here only. So here we have x equal to 2 lambda, y equal to 3 minus z as 2 root 3 over 3 times lambda. Now we are going to substitute the values of x, y, z back into the perimeter equation. So that was x plus 2 times of y, 3 minus square root of 3 over 3 lambda, and this will be plus 2 times of z, 2 root 3 over 3. So my perimeter will become 2 minus root 3 over 2, not this, 4 minus 2 root 3 times lambda. So the dimensions lambda is going to be 2 minus root 3 over 2 times p. Now we will substitute this value of lambda back into these relations to find x, y, and z. So x is 2 lambda, so x is 2 into 2 minus root 3. This and this will get cancelled. X equals to 2 minus root 3 into p. Y was 3 minus root 3 over 3 lambda. And lambda is 2 minus root 3 over 2. And this will be, okay, so this will be basically 2, 3, 2 is 6, and I'll just take the solution from here. 3 minus root 3 over 6 times perimeter, and then we have z as 2 root 3 over 3 times lambda is 2 minus root 3 and this will become 2 root 3 minus 3 over 3 times of p. 2 root 3, 3 over 3, so again the solution given here is correct, and this was a very lengthy question. Good work. This was question number 16. We have question number 17. So how do you find the vertex of a parabola in standard form? Uh, so let's look at the solution given by Junior Tutor. So it is finding the vertex of parabola in standard form. A quadratic function can be written in the standard form as f of x as ax square plus bx plus c, where a is the leading coefficient, b is the middle term coefficient, c is the constant or y-intercept. Its graph is called a parabola, which is a plane curve that is approximately U-shaped and is symmetrical about the middle line called the axis of symmetry, The vertex of the parabola is the point where the parabola crosses its axis of symmetry. So if a is greater than 0, the parabola opens upward and the function has the lowest point minimum value. While if a is negative, the parabola um, a is negative, then the parabola opens downward and the function has the highest point maximum value. The minimum or maximum value is called the vertex h comma k, where h is the x value and k is the k value. So this is the parabola. If we have a positive a, then suppose if this is parabola, if this is the axis, so for this kind of parabola we have a positive a, and for this kind of parabola we have negative a. Now according to question, we have vertex and coordinates are h comma k. So let's go with the step to solve the vertex using the standard form. We have the standard form. First calculate for minus b over 2a to get the coordinate of the vertex. Solve for y using the equation given the solved x value. Okay, so what we do here in this equation, we basically calculate the x coordinate, or h can be found by minus b over 2a, and then we substitute the value of h into this equation and we get the value of y, which is going to be k. So for example, we have this equation y equal to x square plus 6x plus 4. We'll calculate minus b, which is minus 6 over 2, and a is 1, so it is negative of 3. Now we'll substitute the value of negative 3 in this equation. 9 minus 18 plus 4, and this will become minus 9 minus 18, this will be minus 9 plus 4, negative of 5. So my vertex will be negative 3 comma negative 5, and this is the vertex of the parabola. So hence in this way we can calculate the vertex of the given standard form of parabola. And correct solution. Good job. This is question number 18. So we need to find the exact value of sine pi by 4. So for sine pi by 4, I can take an isosceles right angle triangle. Nope. A square, then I will make one line from here I will make one line from here and I will use, yep. So let's say this is a right angle triangle, this is 90 degree, and this is also an isosceles triangle. So these angles are going to be 45, and as these are right, as these this is an isosceles triangle. So um, let's say the length of this side and this side is a, and using Pythagoras theorem we have a square plus a square equal to this length. So this will be, say, h square. H will be 2a square, so square root of 2 times a. Now sine pi by 4. Pi by 4 is basically 45 degree. So sine 45 is going to be opposite, which is a, over hypotenuse, which is root 2a, and this a and a can get cancelled. So I have sine 45 as 1 over square root of 2. I can multiply both these sides with square root of 2, and another simplified form will be square root of 2 over 2, 1 square root of 2, then pi, opposite over hypotenuse. So we can also find the exact value of sine pi by 4 using a unit circle, but in this case I just use the isosceles right angle triangle. So the solution given here is correct. Good job. So that is pretty much for all this session, and if you like this session you can just mention in the comment sections below, and you can also hit like and subscribe button, and you can also hit the bell icons to stay updated for our next live stream videos. And if you need any tutoring help, or if you need any one-to-one sessions, or if you want to submit your own questions, or if you want any homework help, then you can check the links in the description below. And this is Devansh, senior tutor at OneClass, and I will see you in my next video. So hope to see you soon, and for now let's just end this session, and bye.